Recording, just give me a...
This meeting is being recorded.
Okay, then can I continue now?
Yeah, and I'm gonna leave. Bye.
Okay, thank you. Hi guys. My name is Kamohelo Masakala from Enlight e-Tutors. So today I'm gonna be presenting you guys with something really special right now. I'm gonna be doing physical sciences, as you can see from my heading right there. I'm gonna be doing physical sciences, and the topic for today is momentum and impulse. Now, before getting into the gist of it all, I want to explain for today. Before getting into the gist of it all, I just want to explain a few things. Now, as we know from grade 10 and grade 11, we have physical quantities. Now, we have two types of physical quantities, namely the scalar quantity and the vector quantity. Now, the scalar quantity is the physical quantity that only has the magnitude. The scalar quantity is the physical quantity that only has magnitude, and then the vector quantity is a physical quantity that has magnitude and direction forward. Now, our vector quantities can either be designated as a positive when choosing direction, and then or a negative. It will be depending on which direction your vector quantity is traveling at forward. Now, and then we have another thing we call velocity and acceleration. Now, getting into the gist of it all, as you can see from the definition right there, is that momentum, the definition for momentum, the linear momentum of a particle is a vector quantity equal to the product of an object's mass and its velocity. Simply, it means that momentum is mass multiplied by the velocity of a moving object. And as you can see now, momentum is simply designated by what? By P. By P right there. And every single time when you're doing your calculations, every single time, people, we have to know, or like our SI units, we have to know what your SI unit is in order for you to get complete marks, because using different SI units will simply mean that you were calculating something completely different. Now, the SI unit for momentum, it's kilograms meters per second, and you have to include your direction. Why? Because momentum is a vector quantity. Now, as we also explained before, our vector quantity is a physical quantity that has magnitude and direction, right? Now, this is why I'm saying your momentum every single time, it's kilograms meters per second, and the direction. The direction might be towards something, away from something, up, down, left, or right. Those are your directions you can have when dealing with momentum. The next physical quantity we have in momentum, it's the mass. Now, our mass every single time in physics, guys, please pay attention. In physics, mass is always calculated. It's always in kilograms, always. Even if they give you your mass in grams, milligrams, micrograms, or any grams there is available. When you have to convert your grams into kilograms every single time. Okay, so please let us not make mistakes, people, when writing tests or anything like that. Every single time your mass has to be measured in kilograms. And then the last but not least one, we have the velocity. We're measuring it in meters per second. Now, Barry, momentum is directly proportional to both the mass and the velocity of an object. Now, this simply means that if momentum is directly proportional to something, it simply means that when our momentum is decreasing, if our momentum is increasing, it means that the velocity is also increasing. Ne? And then if a mass of an object, even if a mass of an object is increasing, it means that our velocity is also increasing. That's what they mean whereby momentum is directly proportional to the mass and velocity of an object. Simply means that if an object's velocity increases, then its momentum is going to increase. Ne? And then if an object's mass increases, then its momentum will also increase. You feel me? So if they both increase, the velocity and the mass, if they both increase, then that simply means still your momentum is still going to what? To increase. Okay. And now this right here, it's our beautiful formula for momentum. Momentum is equals to P is equals to M multiplied by V. Going to an example. As you can see from this question here, we are given that a soccer ball of mass 420 grams right there. Let me just use another color real quick. Thank you. Now, 420 grams. Guys, remember, 420 grams. I talked about something regarding the mass. I talked about something regarding the mass. Talked about something regarding the mass. Now, a ball of mass 420 grams is being kicked at 20 meters per second towards the goal post. Now, what's the question? Calculate the momentum of the ball. Calculate the momentum of the ball. Now, in this scenario here, here's our ball, right? Here is our ball. Now, this ball has a mass of 420 grams, right? Now, this ball of ours is being kicked towards a pole until it reaches this point there on that pole. Now, what we want to know is what's the ball's momentum from here until here, until it reaches this pole right there, right there. That's a simple way of illustrating what is being wanted from our question right there, right? Now, how do we tackle this? You have to write down every single thing, guys, you are given. You have to write down every single thing you are given. Firstly, the mass of the soccer ball, 420 grams. The velocity of a soccer ball, 20 meters per second. And then we want to know what is our momentum. Now, first and foremost, you have to choose your direction. Okay, guys, you have to choose your direction. Now, I drew a little bit nyana buma, a Cartesian plane right there. I drew a Cartesian plane right there, guys. Now, let's say east is positive, and then our east is towards the goalpost, and then let's take west as our negative, and then our west will be away from the goalpost. Okay, guys. Now, east is towards the goalpost and it's positive, and then west it's away from the goalpost and it's negative, right? Now, how do we tackle this question? Firstly, we have to convert our mass into kilograms, guys. We have to convert our mass into kilograms. Why? We got 420 grams right there, right? 420 grams right there. We have to convert it into kilograms. Now, the only way for you to convert mass from grams into kilograms is if you multiply it by 10 to the power of -3 or divide your mass by 1,000. Still, you're gonna agree, you're gonna come to a conclusion of what your mass being 4.2, 0.42, yeah, 0.42 kilograms. Remember, guys, always kilograms no matter what. Now, the mass of our soccer ball now is going to be 4.2 kilograms. Yeah, 4.2 kilograms. Okay, and then we're gonna have to go to our formula. Here's our formula. This is a very important formula when dealing with momentum, guys. This is a really, really, really important formula when dealing with momentum. Now, firstly, we have our mass right there. We have our mass, and we determined our mass is going to be 0.42 kilograms. And then we have to like substitute it right there. and then our velocity, now our velocity, it's 20 meters per second, 20 meters per second towards the goalpost. Now, what did I say about the goalpost? Our goalpost, towards the goalpost will be east, and then we will have a positive sign in front of our velocity, meaning our velocity in this instance is a positive quantity, guys. It's a positive quantity in this instance. That's why we have a positive 20 meters per second. Yeah, that's why we have a positive 20 meters per second. Now, 0.42 multiplied by 20 meters per second, we are going to have 4.8.40 kilograms meters per second. Okay, guys. Now our final answer is going to be 8.40 kilograms meters per second. And mind you, this is a positive 8.40 kilograms meters per second. Now, when you're presenting your answer to your teachers or whoever will be marking you, or to whoever will be marking you, when you present your answers, you have to include the direction, guys. Momentum is a vector quantity. You have to include direction every single time you do it. Every single time you do it. Okay. Now, finally, you're going to present your answer as momentum. Your momentum will be 8.4 kilograms meters per second in the direction of the post, or you can say towards the goal post. This is why we chose a direction, guys. This is why we chose a direction. Remember, E towards the goal post, west away from the goal post, and towards the goal post is positive, away from the goal post it's negative. Okay, guys, so now let's just take a minute to digest everything I've just said. Let's take a minute to digest everything I've just said before moving on. Now, okay, guys, okay. I'm sure you guys have digested everything now. So that we can do something else, Now, this is a subtopic in the topic momentum. Now we're gonna deal with something I would like to say it's change in momentum, guys. Change in momentum. Okay, it's when something it's going, it's change in momentum, guys. It's when an object is moving like this. And then changes direction because of an obstruction in its way, and changes direction due to an obstruction in its way. And now, as you can see, if an object is moving and changing direction, we can see that we're going to have two different directions, right? We're going to have two different directions. We can choose this direction as positive, and then we can choose this one as negative, right? Now you can see that our object, let's say this round object of ours here, it's moving. Right now, as this object is moving towards the right, it's going to have a positive momentum. And then as it's moving towards the left, it's going to have a negative momentum. That's what we're saying, change in momentum. Right now, if your positive momentum, let's say it's your initial momentum. Say it's your initial momentum. Now your initial momentum is positive, and now you're going to have another momentum. After changing the direction, you're going to have a new momentum, and then we're going to call it a final momentum, which is what? Which is going to be negative. Right now, if you want to calculate the change in momentum, you have to say the final momentum of an object minus the initial momentum of an object. Now, we all know that in momentum, our formula is m multiplied by v, right? Is m multiplied by v. Now, in this instance, we're going to have mass right here. the mass will always, the mass of an object, of one object, guys, the mass of one object is always going to be constant. The mass of one object is always going to be constant. The only thing, the only thing that's going to change here is the velocities. Okay, it's the velocities. You're gonna have your final velocity and your initial velocity. Okay, now because I said the mass, now going about this mathematically, because I know like physics students, you guys are geniuses. We know our math, okay? We know our math now. What we're gonna do right now is that our mass, we're gonna take, because we said mass, it's constant. Now we're gonna take out the mass and then in bracket, we're gonna have VF minus VI, whereby our change in momentum is equal to M open bracket VF minus VI. Okay, now we have different cases. We have different cases of change in momentum, guys. Okay, we have different cases for the change in momentum, and they are they, and they are right there, right there. Different cases for the change in momentum, and you see right there, I still have something great for you. A small and a question right there. Now, let me try to explain what's happening with this different cases. Now, first case. Okay, I'm sorry about that, guys. I'm sorry about that, guys. Now, the first case, a single object right here. This ball of ours, our yellow ball here, is moving towards a wall. Let's call this block of ours here W. We'll call it a wall, W for wall. Ne? It's moving towards this wall. Now, let's choose a direction first. Now, moving towards this wall, towards the wall, while it's moving towards our wall, we're going to have a positive, guys, a positive direction. And then away from the wall, it's a negative direction. Now, why do we have a positive now and why do we have a negative? Remember, our mass is a vector. No, it's a scalar quantity. So signs don't really matter on mass, but our velocity is a vector quantity, guys. It's a vector quantity. Now, this is really important when you're dealing with velocity, right? Now, our ball is moving towards the wall right here. When it reaches our wall, it's going to deflect and change direction, right? Like right here, okay? After changing direction, we're going to have a negative velocity here. And then here is going to be a positive velocity. Now, we're going to have a negative, we're going to have a positive velocity here, which is going to produce a positive initial momentum, right? And then after bouncing from the wall, we're going to have a negative velocity that's going to produce what? A negative final momentum, okay? And then using these two things right here, we're going to have your change in momentum, which is going to be equals to PF, which is our negative PF minus our positive initial momentum. Okay, guys? And then that is that. Now, that's our first case. A ball going towards a wall and then changing its direction. Okay, going towards something with a positive momentum and then changing its direction with a negative momentum. And now you have to like calculate the change. What is the change in momentum in that scenario? Secondly, we have a scenario whereby our ball is going towards something. It's going towards our wall. Still W, guys. Still W. And still, I'm still using my arrows here to depict my directions. Now, towards the wall, guys, positive. Away from the wall, it's negative. Okay, towards the wall, positive. Away from the wall, negative. Now, in this instance, towards the wall, positive VI, and then when it gets here, it doesn't bounce back from like it did in the previous example. When it gets to the wall, it just stops. Okay, guys, it just stops. Now, the reason it stops is because, it's because its velocity became 0. Okay, it became 0 meters per second. That's why it stopped. Now, if it stops, what's going to happen to the final momentum? The final momentum is going to be 0, guys. 0 kilograms meters per second. Okay, that's what happens. 0 kilograms meters per second. Do not forget your SI units, guys. Do not forget your SI units. 0 kilograms meters per second produced from what? 0 meters per second. Okay, guys. Now, if our final velocity it's 0 meters, 0 meters per second, and then producing a final momentum of 0 kilograms meters per second, and we have a positive velocity that produced a what? A positive initial momentum. Now, our change in momentum in this case is going to be equals to negative pi. Negative pi. If you know your math, guys, if you know your math, you know what's happening here. Let me explain my negative pi. We have a 0 here. For final velocity, we have a 0 here, and then minus pi, guys. Minus pi. This is why we have our negative pi. This is where we have our negative pi. If something, if an object, if you get something like an object, a car, a box, a ball, a man running, you see, those are like, they can give you a lot of different things, guys. They can give you a lot of different examples, a lot of different examples. But then if something is going towards a wall and then it stops, if it's going towards a wall and then it stops, just know that it's fine. Its change in momentum is equals to negative its initial momentum. And still bearing in mind, momentum is equals to the product of an object's mass multiplied by its velocity, guys. Okay, multiplied by its velocity. Now, moving on, guys, I'm hoping everyone can understand me. I'm hoping everyone can understand me. And this example here, it's still going left and right. Still going left and right, guys. Positive, negative. Okay, still more or less the same as the other two examples. Now let me do this one that whereby we are moving vertically. Let me do this one whereby we are moving vertically, whereby my upward can be positive and my downward movement can be negative. It's kind of related-ish in a way with vertical projectile motion, but then it's not vertical projectile motion. But then if you know vertical projectile, then yeah, you can see that what's happening here. But now let's talk about this. Now, my PI here, no, my ball here or my object is moving downwards, people. It's moving downwards towards gravity. Okay, it's moving downwards towards the ground, people, towards the ground. Okay, now while moving downwards towards the ground, guys, now my downward motion in this instance, my downward motion is going to be negative, and then my upward motion is going to be what? It's going to be positive. Now we know if something is going towards the negative, like I explained in the previous examples, if it's going towards the negative, then I'm going to have a negative velocity that's going to produce a negative initial momentum. Okay, guys. Now, after reaching the ground, our object is going to bounce back up. Okay, our object is going to bounce back up just like that. Okay, now when it bounces back up, our velocity is going to change because we changed what? We changed our direction. Okay, we changed our direction. Now, going up is going to have a positive velocity, Okay, it's going to have a positive velocity and then produce a what? A positive final momentum, guys. A positive final momentum. Okay, now because what's going to be our change in momentum in this instance? Now, because we have a positive final velocity, right? Not a positive final velocity, a positive initial momentum minus a negative initial momentum. This is what's happening using our formula, guys. This is what's happening. The change in momentum will be minus positive, not minus, man. I'm sorry about that. Let me have a do-over real quick, guys. Let me have a do-over real quick. Now, first and foremost, the change in momentum will be positive or positive final momentum, PF, positive PF minus negative PI, initial momentum. Positive final momentum minus negative initial momentum, and now you're gonna have this, and then you can solve this baby right here mathematically. People, you can solve this baby right there mathematically, because what did I say about the physics, people? You have to be good in mathematics if you are going to do physics, people. Be good in your math and know how to manipulate your sciences, your science, not sciences, I'm sorry. Know how to manipulate your science if you want to be good in physics. Okay, if you want to be good in physics, know how to manipulate your science. Now, what's happening here? We have another example, good people. We have another great, beautiful example right there. Okay, now change in momentum. Example for change in momentum. Let's see where I'm at. The Newton's law revisited. Okay. Now, here's where we are, people. Here is where we are. Here is where we are. Now, a tennis ball of mass, 58 grams. 58 grams, guys. 58 grams. This is something else, people. This is something else. A tennis ball of mass 58 grams strikes a wall perpendicularly at 90 degrees. Perpendicularly means at 90 degrees with a velocity of 10 meters per second. And then it rebounds at a velocity of 8 meters per second. It goes at the wall at perpendicularly with a velocity of 10 meters per second and rebounds at a velocity of 8 meters per second. Calculate the change in momentum of the tennis ball caused by the wall. The change in momentum caused by the wall. Now, guys, look. Here's what I'm going to do now. Now, let's say this is the wall they're talking about. This is the wall they're talking about, right? Now, and then this is my beautiful tennis ball. That's not even round, but then it's fine, nice, it's fine. Now, they're saying that this tennis ball of mass, of 58 grams, it's what strikes a wall, this wall right here. When it strikes this wall, it's 10 meters per second. It's 10 meters per second. And then afterwards, it's gonna rebound from the ball. And then what's happening? It's still the same ball of M. It has 8 meters per second as its velocity, guys. And now you're gonna have to choose our direction, okay? We're gonna have to choose our direction. Positive will be towards the wall, and then negative will be away from the wall. Okay, now towards the wall we had 10 meters per second, which is going to be our positive 10 meters per second. I'm sorry about that. Which is going to be our positive 10 meters per second. And then away from the wall, we're gonna have a negative 8 meters per second. Now we're gonna have a positive 10 and then negative 8. I hope you guys understand or understood what I was doing right there. We're going to have a positive 10 meters per second and a negative 8 meters per second, good people. Now that's how we are going to roll. That's how we are going to roll, good people. That's how we're going to roll. Now, let's see what's happening. Now, calculate the change in momentum, delta P. Delta P. Calculate the change in momentum, my delta P, good people. I'm going to calculate my delta P. First and foremost, like I said in the previous example, the very first example I made, mass of an object. Write down every single thing you have, guys. Write down every single thing you have, okay? Write down every single thing you have. The mass, 58 grams. Initial velocity, positive 10 meters per second because it's going way towards the wall. Positive 10 meters per second. And then our final velocity, negative 8 meters per second. It's going away from the wall. Why? It's because towards the wall is east, gonna be like it's positive, and then away from the wall, it's negative. Our west, guys, our west, guys, our west, guys. Now, let's have fun, people. Let's have fun and do this thing. Let's have fun and do this thing. Now, what do we do now? What do we do now? What did I say about mass, good people? What did I say about mass? Mass, you always convert your mass. If they give you your mass in grams, always convert your mass into kilograms. Doesn't matter if they give you into gigagrams, if there's something like that, milligrams, micrograms, nanograms, if there's something like this. But what you have to do is convert your whatever grams they gave you into kilograms, okay? But then if they gave you kilograms, you're fine, okay? If they don't give you kilograms, convert that into kilograms. If they give you anything other than kilograms, people, convert that into kilograms, okay? Now, in our conversion, we're just going to be like 58 multiplied by 10 to the power of negative 3, or again, you can divide it by 1,000. You want to have your answer, it's still going to be 0.058 kilograms, okay, guys? 0.058 kilograms. Now, coming to calculating our delta P, okay? Coming to calculating our delta P, let's start first by calculating our initial momentum, guys, our initial momentum. Now, initially, my good people, initially, the mass of an object, we just determined it and then we converted it at 0.058 kilograms, okay? 0.058 kilograms right there. Now, and our velocity, because it was going towards the wall, if it was going towards the wall, we're going to have what? A positive 10 meters per second. Now, punching that in your calculator, you're going to have yourself 0.58 kilograms meters per second, guys. Kilograms meters per second. Do not, I repeat, do not forget to include your thingy, your SI unit right there. Now your final momentum, not the final momentum. Now your answer will be, the initial momentum will be 0.58 kilograms meters per second, my good people. Going to your final momentum, okay? As you can see here, people, I'm busy calculating your initial momentum and your final momentum individually, okay? Your initial momentum and your final momentum individually, okay, guys? Now, we calculated the initial momentum, we got 0.58 kilograms meters per second. Now, what is our final momentum? Okay, guys, now, our final momentum, the mass is still the same, people. It's the mass of a single object, guys. The mass of a single object. So our mass, it's still the same, okay? The mass is still the same, guys. Now, our mass is what? 0.58. 0.058, I'm sorry about that. 0.058 kilograms. Kilograms. Okay, guys? And then our final velocity is going to be -8 meters per second. Why? Because our ball rebounded and it bounced away from the wall. Good people, away from the wall. That's why it had -8 meters per second. Afterwards, you're just punching in everything and your answer will be negative 0.464 kilograms meters per second. Okay, I hope you guys are understanding me so far. Now, what's going to happen here is this. Change in P or delta P, it's PF minus PI. Final momentum minus the initial momentum. Now, our final momentum, we got it and we found out it is negative 0.464. And our initial momentum, it's now we're going to come down with this negative. It's coming down. And the initial momentum, we found it out, it was positive 0.58 kilograms meters per second. Then you just punch everything in your calculator, solve it mathematically, and you're going to get your answer as 1.04 kilograms meters per second, guys. 1.04 kilograms meters per second. And then finally, our change in momentum is going to be 1 point. Now, children, guys, people watching and everything. Now, look here. The change in momentum will be 1. Your final answer, guys, your final answer, okay? Your final answer. Now, this is you writing down a statement to the person who asked you a question. They said, calculate the change in momentum of the tennis ball. Now, the change in momentum of our ball is 1.04 kilograms meters per second away from the wall, guys, away from the wall. And it is legit. Our answer is legit because this was moving towards the wall and it bounced and it moved away from the wall. Now, because finally our final velocity, it moved away from the wall, it means our final velocity was negative, and then everything, guys, was everything. For now, I'm hoping you guys understood me, and you guys can do like questions based on momentum. I'm hoping like you guys can do questions that are based on momentum. Okay, thank you so much. Thank you so much. Moving on, my good people. Moving on. Let's see. Okay, moving on. Good people, moving on. Now, right now, we are going to do something you did last year, guys. Newton's second law revisited in terms of momentum, though. Now, Newton's second law in terms of momentum, the net or resultant force acting on an object, is equal to the rate of change of momentum. Okay. Now, as per our definition, it's saying that Newton's second law, you know that Newton's second law is more or less like F net is equals to what? It's equals to MA. But in terms of momentum, F net is going to be change in momentum multiplied by delta T, not multiplied, divided by delta T, guys. Change in momentum multiplied by what? By delta T. That's our change in, that's our Newton's law in terms of momentum. And a typical question they can ask you is to calculate the force exerted on a ball in terms due to its change in momentum in a certain number of seconds. Okay, maybe they might ask you something like calculate a ball, né? Let's say a ball of mass m, né? A ball of mass m moving with a velocity of x, moving at velocity x. Wait, guys. Moving at velocity x is moving downwards towards the ground. Okay, it's moving downwards towards the ground, and then they tell you, like, during its motion, before it bounces back up, it's gonna be in contact with the ground. Guys, look, it's gonna be in contact with the ground for 0.2 seconds. For 0.2 seconds. Now they will ask you, what is your F net? What is your F net from this scenario we just depicted here? What you're going to do is this. F net is equal to what's happening now? What's happening? Because I'm really sorry, I don't know what's happening. Okay, it's fine. Now you're going to say F net is equal to change in P over change in T. Okay, guys. Now afterwards, you're going to be like, okay. Now I only have the initial velocity. And I have my mass, which is m, meaning I don't have a final velocity, right? So this means our final velocity is going to be 0 minus our initial velocity, all divided by delta t, the change in time, the time that the ball took to be in contact with the ground, which is going to be our 0.2 seconds. And now what you do right here is that you have to determine your initial momentum, so that you can calculate what is happening, so that you can get your force, which will be calculated in what? Your force, which will be calculated in newtons. So that's more or less how you're gonna use Newton's second law in terms of momentum, guys. And now here's a beautiful question right there. A 50 N resultant force acts on a 300 kg trailer. Okay? Calculate how long it takes this force to change the trailer velocity from 2 meters per second to 6 meters per second in the same direction. Assume that the forces acting are right, which direction of the motion of the trailer. Now, I'm not going to do this question, but I'm only going to break it down for you guys so that you can understand like what was happening on this question. Now, F is equal to 150 newtons, guys. It's 150 newtons. Act on a trailer of what? M. This is our M, guys. Acts on 300 kilograms, kg. This is our mass, kgs. And now, firstly, how long it takes. You have to calculate delta T. And then your initial velocity to change from 2 meters per second, VI, is equal to 2 meters per second. And then VF is equal to, VI. And then VF is equal to like 6 meters per second in the same direction. So let's say they are both positive because they are both in the same direction. Now, with all this information you are given here, good people, you can somehow do this. F net is equal to, we know that change in momentum is what? It's mass, mainly mass minus, in brackets, the final velocity here, it's 6 minus 2, which is your initial velocity, and then all divided by what? The delta t that we are looking for, guys, the delta t that we are looking for. Now, we know that our force is 50 newtons, and then our mass is 300 kgs, 300 kgs, okay, multiplied by, and then 6 minus 2, that is 4, and then all divided by delta t, all divided by delta t. Okay, guys. Now, what you're gonna do here is that you're gonna cross multiply everything. You're gonna cross multiply everything. After cross multiplying everything, you're gonna have 150 delta t is equal to what? 300 multiplied by 4. I don't know what that is. Don't have my calculator with me, but then I will just do this. Multiplied by 4, and just write it down like that. And then when I have 150 divided by 150 both sides. Why are we dividing by 150 both sides, guys? We are solving this mathematically, so you want to make your delta t the subject of the formula, okay? You want to make your delta t the subject of the formula. Now, 300 multiplied by 4, 3, 6, 8, 12. That's 1,200 divided by 150. I think you guys will have to solve that one for me, and then that's how you would have had to solve this problem. Okay, guys, that's how you would have had to like solve this problem. Okay, so guys, next time when we meet, I'm going to be doing conservation of momentum with you guys. Okay, I'm going to be doing conservation of momentum with you guys, and the only way you can get to meet me, let me just do this real quick. The only way, guys, you're gonna get to meet me, I just want to show you my face real quick. Just want to show you my face real quick. If only this thing will allow me to show you my face. Okay. I'm sure you guys can see my beautiful face. You can see me right there. Now, the only way you guys will be able to catch me, Kamahelo Masakala, right there, you can see me now. The only way you guys will be able to catch me is if you subscribe, okay? Is if you subscribe to our company Enlight e-Tutors, and then you're gonna get a chance to work along with me and some other of my tutors, okay? And a lot more people are there in our company. So subscribe and register with our company Enlight e-Tutors, so that next time we can continue with whatever I was doing here, conservation of linear momentum, guys. Now, this is all from me for today. I would really like to say thank you for joining me. It was really amazing to be hosting you guys doing the momentum and the impulse. I will catch you guys next time. Thank you.